Now see here, speed of efflux or Torricelli's law. Actually, the speed of efflux also can be calculated using Bernoulli's principle. Suppose you have taken like this a container here in this way, in which water is filled and its height from the ground is, suppose this is h, and now a hole is made here, a narrow hole that is called orifice, it is made here, and now the liquid will flow through this hole out. The velocity with which the liquid is flowing, that is v, and this is known as speed of efflux. Now if you choose 2 points A and this is the point B here. So total energy at the point A is equal to total energy at the point B according to Bernoulli's theorem. So this height we can take, that is small h, so remaining height is here, this from the ground is h minus h. So we can apply at this point atmospheric pressure. So Pa plus half rho, that is the density, here V1 square at this point, plus rho gh is the potential energy at the point A, is equal to Pa, because it is opening, so pressure at B is also atmospheric pressure, plus half rho V2 square plus rho g h minus h. So the total energy at A is equal to total energy at B. Now if the area of this, suppose tank is very large, area of cross section, so the velocity at the surface will be very less, because the liquid will be falling down with the very small rate. So we can take V1 is equal to 0 and V2 is equal to here V. So now we can Pa, atmospheric pressure here and here, that will get cancelled from here. This will become now here 0. So we will be getting rho gh is equal to half rho v square plus rho gh minus rho gh. This will get cancelled, and now you will be getting, bring to this side. So you will be getting here half rho v square is equal to rho gh, this cancel. So v square is equal to 2gh and v is equal to under root of 2gh. So this is the velocity or the speed of efflux. So see here, if the hole is made h meter below the upper surface, then the liquid is coming out with this speed v equal to under root of 2gh. And see here, if the ball is also dropped from the same height freely, then also the, after falling through the height h, velocity attained by the body is also the same thing. So this is actually known as also Torricelli's law. By using this velocity also you can calculate till what distance this liquid is falling, that range you can calculate. You can also calculate time taken by this liquid to reach to the ground.